Okay, you're going to need your trig table graphic organizer for this homework lesson, for this homework set, beginning with 383. It says to use your trig table graphic organizer from problem 3-82 to help you determine the value of each variable below. So remember, you should have your ebook open to this problem and have a tab. This is lesson 3.2.2, how important is the angle, and we're beginning with 3-83. And you do need to sketch these 3 triangles, so pause the video, sketch your first triangle, and let's talk about how to find the angle theta. So remember, this is pronounced theta, and that is just the Greek lowercase t. To find this angle, why did I put 95 degrees right there? That's just 95. We are looking for x. So I'm going to look at this slope triangle for 79 degrees, which I have on my trig table graphic organizer. And the slope for 79 degrees is 5/1. The rise is 5, the run is 1, because that's the complement of 11 degrees. 11 degrees and 79 degrees are complements, and that means they add up to 90 degrees. And we saw in our very first example that an 11-degree angle has a slope of 1/5. So then we figured out that if we're looking at this angle, which would be 79 degrees, then we can't see it if it's not tracing paper, but if you rotate this and reflect it, your rise and your run are instead now 5/1. So I know that my rise over run for this angle is always going to be 5/1. So in this case, my rise is 95. So I know that 95 divided by something is going to reduce to 5/1, because remember, all slope triangles on the same line are similar. So I have a proportion, because I know that whatever the rise over the run for this particular triangle is, it's going to be the same as it is for any right triangle that has a 79-degree angle. And then if I cross multiply, I would get 5x equals 95, the cross products of 2 equal ratios. Remember, these are ratios, are always equal. So if I divide both sides by 5, I get x equals 19. So this side must be 19. Okay, looking at part B, we have another slope triangle. And here we're looking for the angles. And we know that the rise over the run is, if I'm looking at this angle, angle A, the rise over the run is 40/40, and it's the same if I'm looking at B. Well, 40/40, that reduces to 1/1, which is just 1. So if you look at your trig graphic organizer, the slope of 1 corresponded to an angle of 45 degrees. The rise and the run was 1. So this angle must be 45 degrees. And so is B. So A equals B equals 45 degrees. And if you think about it, a 45-degree angle, isn't that half of 90 degrees? So that's just going up 1/1, up 1/1. That's just a slope of 1. Okay, part C, we have an angle of 22 degrees, and I could work with this angle, or I could find the complement, because I know that these are going to add up to 90 degrees. So 22, if you could do it the long way, you could add in 90, but we know that all the angles, oh, I'll start the long way. Okay, 22 plus 90 plus something equals 180. Since I know this is 90, if I subtract 90 from both sides, I get 22 plus something equals 90. So basically, whenever you see a right angle, you know that these two angles must add up to 90 degrees. So you should know that moving forward, and I'm not going to do this the long way moving forward. So if I subtract 22 from both sides, I get x equals 68. So I could work with the 68 degree angle, or I could work with the 22 degree angle. I've got both of them on my graphic organizer. The slope ratio for 22, double 11, was 2/5. The slope ratio for 68 is just going to be the reciprocal of that, so that's going to be 5/2. And since we already have it drawn looking like the slope triangle corresponds to 68, let's just keep it that way. If I were to look at the 22 degree angle, I would rotate it. I would also probably reflect it, although you don't have to, because you can see the rise is just 70 and the run is y. So if that makes more sense, you can do it that way. So we know that for a 68 degree angle, the rise over the run is going to be 5/2. The change in y over the change in x, rise, remember, is your change in y, and run is your change in x. It's 5/2, and that's going to be true for any right triangle that has this as an acute angle. 68 degrees is one of the acute angles. It doesn't matter how big the triangle is, how small it is. If it's a right triangle and one of these angles is 68 degrees, the rise is going to over the run is going to reduce to 5/2. So I'm going to set up a proportion that something divided by 70 is going to reduce to 5/2, and then you might be able to see what it is just looking at this. If not, cross multiply. 5 times 70 is 350. 2 times y is 2y. Divide both sides by 2. So that's going to be, let's see, 150 would be half of 300, and then 25 would be half of 50. So 175. Okay, moving along, 384 is related to something that we haven't done yet. So I'm just going to quickly review the math notes. They're in lesson 3.2.1. It's not very difficult. And I don't think it's going to be on PSAT, but it does pop up. If it's in this book, chances are you're going to see it again if next year. So let me find these math notes. 3, 2, 1. Here it is. Okay, so expected value, the amount you would expect to win or lose per game after playing a game of chance, is called expected value. It doesn't need to be a possible outcome of a single game, but instead reflects an average amount that will be won or lost per game. So what you're going to do, for example, look at this one. The $9 portion of the spinner makes up, that's 30 degrees right there, so 30 out of 360 would reduce to 1/12 of the spinner. The $4 portion is everything else, so that would be 330 out of 360, which would reduce to 11/12. That means if the spinner is spun 12 times, the probability predicts that it will land on $9 once and $4 11 times. So the expected winnings for the game for 12 spins would be 1 times 9 plus 11 times 4, 53. If you played it many times, you would earn an expected value of, you take that total amount, 53, divided by 12 spins to get $4.42 per spin. So you figure out the amount per spin. You could use this value to predict the result for any number of spins. For example, if you play 30 times, then you would just do 30 times $4.42. So another way to calculate expected value involves the probability of each possible outcome. Since $9 is expected 1/12 of the time, $4 is expected 11/12 of the time, then the expected value can be calculated with the expression 1/12 times 9 plus 11/12 times 4, $53 divided by 12 spins, $4.42. And a fair game is one in which the expected value is 0. So that is, a game is fair if over many plays a person would expect to neither win nor lose points or money by playing the game. Okay, so looking at 384, it says the probability of winning $3 on the spinner at right is equal to the chance of winning $5. So that's their way of saying that this is equal to this. This section of the spinner is equal to this section. Calculate the expected value for one spin. Is this game fair? Okay, so calculate the expected value for one spin. We're just going to figure out the degrees for this section and this section. So remember, a full circle is 360 degrees. We have 90 degrees right here. So 360 minus 90 would be 270. And then they told us that the probability of winning 3 is the same as the probability of winning 5. So we know these are equal. So we're just going to divide that by 2, which would be 135. So this is 135 degrees. And this is 135 degrees. This is 90 degrees. So I'm just going to multiply $3 times 5 over 360. And then I'm going to add $5 times 135. Whoops. Over 360. And then I'm going to subtract $6 times 90 over 360. Now that's going to be kind of challenging if you don't have a graphing calculator at home. Let me show you with the... Okay, I'm going to try and use this calculator when I'm making videos so that you can connect it to the ones we have in class. So remember, you should always press your scratch pad button. A lot of you are still using documents. Documents don't have as many features as the scratch pad. And then I'm going to enter this. I'm kind of looking at the lighting. Okay, let's see if we can get this to show up. 3. No, it's not going to show up. Let's do Well, I don't know if you're going to be able to see this. Let's see. 3 times. Hold on a second. Let me pause. Okay, so I typed in 3 times 135 over 360. I typed in all of this. It's kind of hard to see, but that 6 is negative, and I got 3 over 2. So that means the expected per spin is $1.50, and that means the game is not fair because the expected value is not 0. If it were a fair game, then your chances of winning versus losing would amount to 0. Okay, for 385, we've got some diamond problems. It's been a little while since you did this, probably. So, quick refresher, you're multiplying, you're getting the product on the top, and then you're getting the sum on the bottom. You're adding for the bottom. And we've got some fractions in here, so I'm probably going to need, let's see, Get some scratch paper in case I need to show a little extra work. So take a second and draw your diamonds. Pause the video. So here we're looking for what number times -1 would give us -4/3. Well, anything times 1 is going to be itself, right? So 4/3 times 1 would be 4/3, and then if you multiply a positive times a negative, you get a negative. So this has got to be 4/3. And then if I add 4/3 and -1, remember when you're adding fractions, you need a common denominator. So -1 is the same as -3/3 if I use a denominator of 3. And if I add 4 and -3, that would give me +1/3. Part B, we're looking for what the product of -3/5 and -4/5 would be. Negative times negative is a positive. When you're multiplying fractions, you multiply the numerators and the denominators. So that's going to become +12/25. When you are adding the fractions, you're just adding the numerators. -3/5 and -4/5 is -7/5. Okay, part C, we're looking for what number we could add to -1/6 to get 1 and 5/6. So I'm going to make a little equation out of this, and I'm going to turn 1 and 5/6 into an improper fraction. If I multiply 6 times 1, that's 6. 6 plus 5 is 11. This would be 11/6. So I'm going to ask myself, what plus what plus -1/6 equals -11/6? And that's the same as writing x minus 1/6 equals -11/6. So I'm going to add 1/6 to both sides. And that would give me, now I'm adding, so that means I'm adding the numerators. -11 and +1 would be -10/6. And that can reduce to -5/3. I just realized I put a negative right here, and this is not negative. This is +11/6. So that's going to change this. Sorry about that. Where did I get the negative? Oh, I was looking at that equal sign. Okay, so add 1/6 to both sides. That would give me 12/6, which would reduce to 2. So this is +2. And then if I multiply 2 times -1/6, that would be negative. Remember, 2, when you're multiplying, 2 is the same as 2/1 times -1/6 would give me -2/6, which would reduce to -1/3. So this is -1/3. Nice little review of adding and multiplying fractions. And part D, we have two numbers. We're looking for two numbers that when we multiply them, we get 1/16. And when we add them, we get 1/2. Well, if I'm multiplying two fractions to get 1/16, I know the numerator is probably 1. And then what times what is 16? 4 and 4 is 1/4 plus 1/4, 1/2. Yes, 1/4 plus 1/4 is 2/4, which would reduce to 1/2. Okay, don't be afraid of fractions. They're not that bad. And you can always, that's a nice thing about these calculators, whether it's this one or the older version, if you're struggling with fractions, you can use it to your advantage to kind of check and see if you did things right. Okay, 386. Which equation below is not a correct statement based on the information in the diagram? So let's check out each of these statements. And yes, I do want you to draw this diagram in your notebook and use it and mark on it like I'm going to do in the video. So this says 3x plus y equals 180. Let's see if that's true. do these two angles add up to 180? So you're going to have these problems on the interim exam. This is a great review, and by the way, we do have parallel lines. We've got the arrows showing these are parallel, these are parallel. So if I take my tracing paper and I trace this angle and I translate it so that the vertex, this is the vertex of the angle, I make it line up with the vertex of this angle, these two angles add up to 180. So that statement, 3x plus y equals 180, that's true. Let's try part B. 2x minus 1 equals 4 minus x. Okay, look at these two angles. Are these two angles equal? Now, some of you are going to say, yeah, that's 90 degrees. The way I've drawn it, it kind of looks like it's 90 degrees, but if you look in the book, it doesn't quite look like 90 degrees. I'm trying to make the point that if you don't see a 90-degree angle, you don't assume that it's there. So actually, we don't know if these are equal to each other. We do know that they add up to 180, but that would be the statement that's not true. Part B is not true. I do want to go through the rest of these just because this is going to keep coming up. It's on your interim exam. 2x minus 1 equals 5y minus 10. Looking at these two angles, let's trace this angle here. And it's good to use the lines of your notebook paper to make sure that if you sketch this, that you're actually sketching parallel lines, at least for one pair, and that'll help you when you do your tracing paper. Okay, if I slide this over here, you can probably see already these are vertical angles. They're going to be congruent. If you couldn't see it, if you rotate it and map it on top of the other one, yes, these are equal. Those are called alternate interior angles. Okay, and then our last statement would be 2x minus 1 plus 3x equals 180. Let's check this out. And I shouldn't have drawn it so that it looks so close to 90 degrees, because then you wind up with, it's a little misleading to think that some of these angles are always going to be equal to each other. So let's trace this angle, and let's bring it down here, and then this is a half circle, so those are going to add up to 180. Let's just go ahead and mark which ones would be equal. Put something under here. So we said that this angle would be equal to this angle. And then we said that these would sum to 180, these two together. And we said that that's a half circle. So that's 180. And then I think the last one we translated this over here. These were equal to each other. Okay, hopefully those con exercises have made you feel mastery of that. It doesn't hurt to go back and do some of those. Okay, this is a great review problem for solving systems of equations. There are some math notes in lesson 2.1.3 on solving systems of equations. I'm not going to read through every part of that, but I do want to kind of refresh your memory that substitution is a way to solve a system of equations. Remember, this is in lesson 2.1.3, and I'm sure you spent a lot of time on this last year. Substitution is nice when you have one of your equations in terms of one variable and the other one is not. Then you can just take this and swap it out when you see x. For example, on this one, you're just swapping out for x this expression. So substitution is nice for when you have that. Elimination is nice when you have both of your equations in standard form, And when you have the y's on top of each other, when you line them up, and the x's on top of each other, and you can manipulate things to make it look like that, but it just makes it nice to either add and subtract to get rid of one of those variables. And then the last one is setting them equal to each other, which I'm noticing they don't show an example of in this math notes, that's what we're going to do on this very first one. And I guess you could consider that substitution. That's probably why they don't do anything with that. So you may have done this with graphing last year. That's an excellent strategy. But let's do this algebraically. So I'm going to swap out 5x minus 2 with y. So I'm going to switch these out, or if you want to think of it as I'm just setting these two expressions equal to each other, because if y equals 5x minus 2 and y equals 2x plus 10, then 5x minus 2 must be equal to 2x plus 10. And then I'm just going to solve for x, because if you've got two variables in your equation, that's an infinite number of solutions. If you've got one variable, you have one solution. I've got x's on both sides. Get rid of the smaller one. Solve for x, add 2 to both sides. Divide by 3, so x equals 4. Now I'm going to take that and substitute it into either one of these. So then y equals 5 times 4 minus 2. So then y equals 20 minus 2, which would be 18. So my answer would be 418. And you could get that by graphing the two equations. They would intersect at the point 418. Okay, part B, we want to use substitution because we've got one of our equations in terms. So I'm going to rewrite this equation, and when I see x, I'm going to swap it out with negative 2y minus 1. So we're substituting for x in the next expression. So 2, and instead of writing x, we're going to put negative 2y minus 1 plus y equals negative 20. All I did was switch that out. And now I have an expression with one variable. I can solve for one solution. Here I cannot solve for one solution because I've got two variables. That's a line. There's an infinite number of points in a line. Okay, let's distribute. So that would be negative 4y. Positive 2 times negative 1 would be negative 2. Okay, we've got like terms. Negative 4y, positive 1y, that's going to be negative 3y. I'm going to bring down that negative 2, and I could have put the negative 3y in front if that is what you want to do. That's fine. Okay, I actually kind of like to, when I have a negative coefficient, I like to move it over to the other side. Now that does create an extra step, but it avoids dealing with dividing by negatives, which is where students tend to make mistakes. So yes, this is an extra step. No, you don't have to do it, but it's a good thing to check out. So that would give me negative 20 plus 3y. I can't add these together. They're not like terms. And then I would isolate y and get y by itself. So I would add 20 to both sides. Divide by 3, and you're not dividing by a negative, and I would strongly encourage you to do that when you have a negative coefficient for the variable that you are solving for. Okay, 388, I do want you to draw these. The question is, I lost my page. For each pair of triangles below, decide whether the triangles are similar and or congruent and justify your conclusion. So this is great review. Looking at these two triangles, I cannot assume this is 90 degrees just because it looks like it's 90 degrees, so don't even think about it. And then I'm just going to look at these sides, and see if they are in proportion. Because remember, let me find this page. So the conditions for similarity are in lesson 2.3.2 in the math notes. We went over this super fast one day because people needed time to work on Khan. We didn't do the full lesson, and I'm a little concerned that not everybody gets this. So when you are looking at two triangles, there are ways to determine if they're similar without measuring all 6 angles and all 6 sides. So if you're looking at two triangles and you have 2 angles congruent to 2 angles, then the triangles have to be similar, because if these 2 angles are the same as these 2 angles, then you know that third angle has to be the same, which means this is a dilation, one is a dilation of the other, and that's called angle-angle similarity. Side angle side is a condition for similarity. If I can multiply by the same factor and multiply b by that same amount and get the new sides, then this must be a dilation, this must be a dilation of this, as long as that angle that's included between the 2 sides is the same. In other words, if these 2 sides reduce to the same ratio and these 2 sides reduce to the same ratio as these 2 sides, then your triangles are going to be similar by SAS as long as the angle in between them is equal. We played around with this on the e-tool, although one class I don't think we even did it because there were a bunch of kids on a field trip. But this is called side angle side similarity. And then the last example, and this is, if you don't get this, I would read through these math notes because it is the foundation for knowing quite a few of the questions that we see on exams in future tests. They're not going to just tell you that the triangles are similar. They're going to set up a situation and you're supposed to figure out that they're similar. SSS is a condition for similarity. If this side divided by this side is equal to this side divided by this side is equal to this side divided by this side, here's a picture of what I just said, then your triangles are similar. So you can know that the triangles are similar without even knowing the angle measures if your sides are in proportion. If you can multiply all 3 of these by the same scale factor and get your new sides, then the triangles are similar. So let's quickly do this question. Let's set up our ratios. Let's look at the ratio of 6/9. I'm picking the 2 smallest sides and comparing them. Then I'm going to pick the 2 middle sides. And then I'm going to pick the 2 largest sides. Now, you may know already what these reduce to. If not, you could use a calculator. Your calculator at home is probably going to give you a decimal. The one at school would reduce to lowest terms. 6/9 reduces to 2/3. 8/12 reduces to 2/3. And 9/13.5 reduces to 2/3. Now, if you did this at home, you probably got 0.6 repeated for all 3 of those. That means that these are similar by SSS. Okay, part B, we have parallel lines and we've got overlapping triangles. Whenever you see overlapping triangles, just do yourself a favor and separate them, and don't argue with me about drawing them separately. Okay, this angle is shared by both triangles, so that angle is the same. If these 2 lines are parallel, you've got parallel lines cut by a transversal here and a transversal here. I'm only going to look at this set of angles here and this set of angles here. I know they have to match if the lines are parallel, so I know this angle must be the same as this angle. So that means this angle here must be the same as this angle here. Let's do 2 arcs to show that these 2 are equal, but they're not all 4 equal to each other. And those 2 triangles would have to be similar by angle. If these 2 angles equal these 2 angles, this angle that's left must be the same as this angle right here. Okay, part C, we have an angle of 90 and an angle of 90. We have a side that's 6 and a side that's 6. In none of our conditions, whether it was congruence or similarity, was having a side and an angle enough to determine that they were either congruent or similar. So not enough info. Okay, and then part D, we have two isosceles triangles. And remember, in an isosceles triangle, your base angles are equal. So this would be 72 degrees here. And I could figure out this angle right here by doing 72 plus 72 plus x equals 180. That's going to give me 144 plus x equals 180. So x equals 36. So this angle is 36. If I were to find the missing angles here, they would be 72 and 72. So the angles are the same. So then these two triangles are similar by, there's actually several answers. You could say angle, angle, and actually this side is the same as this side, so they're not just similar, they are actually congruent. Scratch that. They're congruent by angle, side, angle. And because I found all the sides, I could say angle, angle, side. So these are not similar. Well, you could say they're similar with a scale factor of 1, but they are congruent by either angle, side, angle, or angle, angle, side.